factor are obviously going to be easier to do because we already know how to factor. But the ones that don't factor require like a lengthy process that we'll learn in sections 5 and 6. So, for example, we have here a cubic function, or a cubic equation, that we want to solve. So we're going to find both the real and imaginary zeros. So for everything in chapter 5, you're just going to assume you're always finding real and imaginary, okay, unless it just says real. Which means if you get to like a sum or difference of cubes, you have to factor it. If you get to, you know, like x squared equals -4, you have to like keep going and get imaginary answers. And if you're using the quadratic formula or something, you want to keep those imaginary ones. So in order to solve anything for solutions or zeros or roots, we need it set equal to 0. So I need to get this 3x over to the right or left side of the equation. So we're going to subtract it and keep it in descending order. Okay. If it's in descending order, then when we look at it, we'll be able to know if it's factorable or not. So from here, I can factor out a greatest common factor. So what would that be? X. Yeah. So once you do that, you can see we have a quadratic equation here. Now it's up to you if you want to like attempt to factor it or complete the square or quadratic formula, but we want to solve this somehow. So before I do that, I'm just going to split this up. We have x equal to 0 and we have 2x squared minus 5x minus 3 equals 0. So that's our zero product property, and we have one solution already. And then this quadratic you can solve however you want. So if it factors, usually that's easier, but if it doesn't factor, usually the quadratic formula is the way to go. Is there a number that multiplies to -6 and adds to -5?
6 and 1.
Yeah, okay. So that first set that I wrote down. So we got 2x squared plus 1x minus 6x minus 3 equals 0. We want to take out a greatest common factor out of the first two. So what are we going to take out?
I took out an
X. And then you're left with 2x plus 1. And then the second group, we want to take out a -3, and then we're left with 2x plus 1. So our factors are x minus 3 and 2x plus 1. Then you want to take both of those and set them equal to 0. So you should get x equals 3. Here we want to subtract 1 and then divide. So x equals -1/2. So because it is a cubic equation, we should have 1, 2, 3 solutions. They don't necessarily have to be 3 distinct or not like unique solutions. You could get 3 of the exact same answer. You could get like x equals 1/2 4 times for a quartic, and that's still okay. But in this case, we got 3 different ones. Alright, so you're going to subtract the 5x to the 4th, and you're going to add the 2x cubed, and you're going to keep everything in descending order. So x to the 5th minus 5x to the 4th, and you should have plus 6x cubed equals 0. Factor out an x cubed.
I don't know how you got that many zeros. X cubed equals 0. X cubed equals 0.
So that's 3 zeros automatically.
Wait, that's 3 zeros?
Yeah.
Alright, so this factors to x minus 2 and x minus 3. So then you have
Oh, Luke.
x equals 3 with a multiplicity of 1, x equals 2 with a multiplicity of 1, and then x equals 0 with a multiplicity of 3.
I only put the multiplicity on for 0.
That's fine, yeah.
Oh, yes, please. Look what I found.
Sometimes I just write like times 3 or
I have
mult 3.
like 3.
Yeah.
What am I looking at?
Did I do it right?
You have the kind of right answers except they're supposed to be positive.
Not going away. It's forever gonna stay.
Ew,
All right.
why do you keep doing this?
They're not going away. So I just rewrote them there for you, but you should already know them.
Is a cube of 81 3?
So
No.
before you just assume it's a difference or sum of cubes, you want to see if you can like factor anything out or divide by anything. Is there anything to factor out or divide by?
Divide by 3.
Okay, so there's a constant we can divide by 3.
Is that 27? I don't know why. Is it really?
Yeah, it is.
Wow.
She was right the first time. Don't worry.
All right, so x cubed plus 27. So in order to factor it, so it's a sum of cubes. In order to factor it like a sum of cubes, you need to know what cubed is x cubed and what cubed is 27.
See, I was thinking it's 3.
It is 3. So 3 cubed is 27. So that means that x is a and 3 is b. And we're basically going to plug all those in and factor this. So this factors to x plus 3 times x squared minus both of those together, so 3x, and then plus 3 squared, which is 9.
Would you like me to answer the
I need to pause. All right, so what you're going to do is you're going to take both of these factors and set them equal to 0. So I'm going to move this one over here because I'm going to run out of room. Okay, when you set x plus 3 equals 0, you get the nice and easy x equals -3. That is going to be your one real solution. So when you solve for sum of cubes, difference of cubes type questions, you're always going to have one real and two imaginary, which means this quadratic thing that you've created will never factor. Yeah, you can either. Yeah, I don't want to either. So,
I'm not in the quadratic today.
because if b is odd, then I just don't complete the square. All right, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, something's under my paper. All right, so then you got to simplify that. So this is going to go off the paper a little bit. So -3 plus or minus the square root. So -3 squared is going to be 9. This is 36.
Is it
9.
-36?
Yeah, so 9 minus 36 is -27. You should anticipate this being a negative number because I just told you you're going to get one real and two imaginary, like every time. Okay, and then the square root of 27 simplifies.
You take like a 3 out, right? You take, yeah 3 and the 3 stays inside.
So you can take out a group of 3's and leave in a single 3. So that's going to change to 3 plus or minus 3i root 3. Just don't forget the I because it is
I
imaginary.
already put my eye on the end. She just like looks weird just sitting in the middle of there.
I was trying to stay consistent with Math Excel, so I don't know.
It takes both.
Whatever Math Excel wants, I don't particularly care.
I think it does. It takes mine.
So these are examples of like quintics that are factorable using the grouping technique. So you're going to split this up into two groups. Okay. And you're going to do what you usually do. You're going to factor out a greatest common factor.
Okay, I keep writing like the number instead of the x.
So what would be the greatest common factor here? We have x to the 5th and x to the 4th.
X to the 4.
Right. And what would we be left with?
X to 1.
X minus 1. Now, is there a greatest common factor here?
It is 1.
It is 1, and we're actually going to take out, since this is a minus, we're going to take out a -1. So that's going to change this to x minus 1.
What is happening right now? My pencil's being
So you just want to make sure that you should be able to distribute and get the original thing, which we can. So our two factors are x to the 4th minus 1 and x minus 1. Now, we know that it's factorable by grouping because the insides were the same when we took out the GCF for each. Okay, so we know that it factors. So they won't all factor like that, but this one does. Okay? All right, so the next thing we're going to do is we are going to take these two factors, so x to the 4th minus 1 and x minus 1, and we're going to set them equal to 0.
Is this a long problem? Because I like have no smallpox today.
Yeah, there's a little bit more to it. Yeah, I'm actually going to scoot this over a little bit. So in order to get all the solutions, so in order to get all the imaginary and all the real, you would have to factor this like a difference of squares. The x to the 4th minus 1. So how does this factor like a difference of squares?
Squared.
So x squared, what goes next to it? And? Yeah. If you don't factor it like a difference of squares, then you're not going to get the imaginary solutions. You'll just get like the real ones. So you won't get all of them, which is bad. We want all of them, okay? All right, so we factored, kinda. So let's see. We're going to take x squared plus 1 and set it equal to 0. We're going to take x squared minus 1 and set it equal to 0. So the x squared plus 1 equals 0. I'm going to subtract 1.
It's I. Oh no.
Yes, and then you square root both sides, you get plus or minus I. Don't write 1I, just write plus or minus I. Okay, 1I is not simplified. If you write I1, that's even weirder.
You always need 2 I's.
That's funny.
Yeah.
Yeah.
What?
Okay, then this one we're going to do x squared equals 1, so add 1, square root that. What's the square root of 1?
Plus or minus 1.
Yeah.
Good job.
Thanks, Tristan. Really gave that my all.
I guess I didn't need to move this guy all the way over there.
I like saw you do it, and I just like got in my head before, like wow.
You know, I thought my head, wow.
Like
Just say you're high.
Tristan is on drugs.
All right, so we got,
Like, wow.
I'm recording.
I told you that would be x equals 1.
So, well, okay, so the last one, the one that was from earlier, when we set this guy equal to 0, we got x equals 1. Now, if you were to list all your answers out like individually, you'd have from here 1, from here you'd have 1 and negative 1, and then from here you'd have I and negative I.
I thought we were making like points because you're looking for the zeros.
Oh, no, I'm writing, yeah, you could. You could.
I really could.
Yeah. So, but if you look, we have 1, 2, 3, 4, 5 answers. If you didn't factor the difference of squares here, then you wouldn't have found these two, and you might not have found these two. I don't know. It depends. So, so that's why it's really important, because we want to get 5 answers. So we do get 1 twice, so you could say like your multiplicity of 2 or whatever, and then you have 1 that's negative 1, 1 that's I, and 1 that's negative I. On a graph, if you were to graph this,
Be like 1,
it would intersect the x-axis at 1, at negative 1, and then nowhere else.
Because I
Because I
is
doesn't
imaginary.
exist here. So it either looks like this, maybe, something like that, or it could just
Be a parabola.
do something like this, okay? Because it's a quintix. So quintix either look like super humpy or not that humpy.
that's like a camel.
Yeah. It's like a camel function.
Brandon, just turn.
Okay, so last chapter I was telling you about how to like factor things that are quadratic. So they're in quadratic form, but they don't look quadratic. This is something that is comparable to that question, but is a quadratic equation. So how does this factor?
3 would be -1, -1 and -3.
There you go.
I just want to know why did you put it.
Okay, so now
Oh, yeah.
here, if we have x minus 4 root x plus 3, the reason this is considered in quadratic form is because the square root of x squared gives you, anyone? X, and that's this.
Wow.
So this is in quadratic form, Because you could write it root x squared minus 4 root x plus 3. And that makes this quadratic form.
I don't like this.
Oh my
Yeah.
god.
You don't like this.
Well, give me a minute to just copy this down, try and gather my thoughts.
Yeah.
I need to gather my thoughts.
Let me gather my thoughts for you.
So it's similar to the ones where it's like x to the 6th and x to the 4th. It's similar to those. It's just that it's a square root instead. Okay? So what we're going to do is we're going to factor.
Oh, yikes.
So we're thinking of two numbers that multiply to positive 3 and add to negative 4.
So -1 and -3.
There you go.
Say things backwards, Tris, that's cute.
I said -3.
Now instead of putting x's here,
They do square root.
they're going to be square roots of x here.
Sorry, it's like making me cringe. That makes me like, it feels like unfinished because they're like not.
You make me
This
cringe.
is just so like.
Now I would like you to also keep in mind that this is technically not considered a polynomial equation because the square root of x is not a monomial. So this is like, again, this is added in here for you honors kids so you know how to do this.
It's gonna go to a test.
It will probably be more on a future test. Yeah.
Oh my god.
So basically you're just regularly factoring, but instead of putting x's, you put square roots of x's. Okay, then you're gonna set these two equal to 0.
But you move one to the other side, like x already in the square root, you put one in the square root too. Like,
No, I'm getting there. All right, so look, Braden, focus. We're gonna add 1, so we get the square root of x equals 1. Okay, instead of square rooting, what's the opposite of that?
squaring.
Yes.
Square both?
So we're gonna square both sides instead. Okay, so you just get, what's 1 squared?
1.
There you go, so you get x equals 1.
Oh, is that how you get rid of the
Yeah.
square root?
Mm-hmm.
What do you even call that?
How many answers?
Square
do you
root.
get?
Like,
We're supposed to get 2 answers, right, for this one?
So because this isn't a polynomial function, the like fundamental theorem of algebra doesn't really apply here. So sometimes you get 1, sometimes you get 2, sometimes you could get no
Just
solution.
mix, like, yeah.
So here we're gonna add 3, so we get the square root of x equals 3.
Oh my god.
X
My
equals
eraser
9?
fell out again.
Yeah.
Whoa.
So
You're-
square both sides,
It's crazy cool, guys.
Oh, it's quadratic.
and you get x equals 9.
Is that? That's it, right? We don't have to
And
do
that's it. So
Okay.
usually you check your answer just to make sure, because you can get extraneous solutions sometimes, so I'll just check one real quick. So if I plug in 1, I get 1 minus 4 plus 3.
Oh wow.
Wow. Wow.
Okay. If I plug in 9,
I was doing the wrong question.
so 4 root 9, that's 4 times 3, so 12.
See, that's actually not as bad as I thought it was going to be. It could have been so much worse.
So both of them work. So sometimes you do get extraneous, in this case you do not.
Yeah, I say this now, but I think when I do it by myself.